Hey everyone, it's Dr. Walker. Let's look at another example from v061C on angular momentum. In this one, we're finding the angular momentum of two objects about this point O here. We can treat these objects as particles, so they don't have any kind of significant size or shape. To do this problem, we're going to use the definition of angular momentum for particles, which is L equal r cross p. But we know that the angular momentum is going to be the combination of the angular momentum object 1 plus object 2. So we're going to use r cross p for each one. R cross p for number 1, and then r cross p for number 2. Let's take a look at which way these particles are moving. So particle number 1 here is going to be moving to the right. Let's look at its position vector r. It's from the pivot point to the object. So r actually goes straight up. This would be r1. And v1 is to the right. So you notice that v and r are perpendicular to each other. And we said that was a special case when calculating angular momentum, that it ends up being mvr. Now we do need to pay attention to direction. Do you remember how to find the direction when you have a cross product? R cross p, remember p is in the same direction as v. So when you use your right hand rule, you point your right hand in the direction of r, which means fingers pointing up, and then you fold them to the right in the direction of p. Your thumb should be pointing into the screen. If we use a Cartesian coordinate system here, then into the screen would be the negative z direction, or negative k. And then we're going to look at R2 cross P2. So V2 and thus P2 are going upward. And the position vector R2 goes from the origin to the object. So the position vector points to the right. Once again, R and P are perpendicular to each other, so we're going to have mvr. Is the magnitude of the angular momentum. And what about the direction? Point your fingers to the right, fold them upwards. Which way is your thumb pointing? It should be pointing out of the page, which is the positive z direction, which is a positive k. So what we do is we're going to compute this and subtract our numbers. Well, we're adding the numbers, but the first number is negative. So we're going to have negative, and then our mass here is 6.5 times the v, which is 2.2, times the r, which is 1.5, plus mass 2 over here, which is 3.1, times the velocity, which is 3.6, times the r, which is 2.8. And then when we add these two, our final direction is going to be the k direction here. We're going to get negative 21.45 plus 31.25. So our final answer is going to be 9.8. Don't forget the units. Kilograms meters squared per second in the k direction, or positive z direction. So this problem was a plug and chug, making sure to be able to use the definition of angular momentum for particles and being able to take into account the direction as well using the right hand rule for cross product.